Chapter 32 is infusion rates and drip rates. So the learning objectives for this chapter is after this chapter, the student will be able to calculate the rate of infusion if the volume of infusion and the time of infusion are known, calculate the rate of flow for an IV in drops per minute, and the calibration of the IV set is known along with the volume of the infusion and the time of the infusion. Calculate the rate of flow for an IV in milliliters per hour if the volume of the infusion and time of the infusion is known. Calculate how long an IV infusion will last and determine the military time. Um, Physicians write orders, of course, for rate at which the IV is going to be infused into a patient. So the infusion rates can be expressed as number of milliliters per minute, milliliters per hour, amount of the drug per hour, and often as the length of the time for a volume to be infused. For example, it could be infused at 125 milliliters per hour, or they may tell you to infuse 1,000 milliliters over 8 hours, or infuse 10 milligrams per minute. So if the volume of the infusion and the time of the infusion are known, then the rate of the infusion can be calculated from the following formula. The formula is going to be your volume over time is going to equal your rate. So it's important that when you're and it seems like it is very simple like this, but sometimes the questions will ask a little bit different questions, so you may have to convert or add or multiply after you do this formula. So it's important to make sure that you read your questions completely before finishing it up. So the first one, it says, and I'm not going to write the questions on there, but it's in your book on page 275. If a 1 liter bag of D5W is run through an IV into the patient's arm over 8 hours, what is the rate of the infusion in milliliters per hour? So this is number one. So remember, it's volume, of course, over your time. So it'll equal the rate. Okay. So one thing I want to make you aware of is usually this is given in milliliters, usually per hour. Okay. So look at what the question is asking. So it's milliliters per hour. So you take your milliliters, you have 1 liter. Okay, so we're going to convert that to milliliters. So 1 liter, as it should be a give me, is 1,000 milliliters. Just times by 1,000. Your time, of course, is 8 hours. This one's pretty simple. Starting out easy, you just divide it. And when you divide it, you get 125 milliliters per hour. Number two, if 500 milliliter bag of 0.9% sodium chloride injection is run over 8 hours, what is the rate of infusion? Again, this is volume first, so it would be 500 milliliters over your time, and it's going to be 8 hours. So 500 divided by 8 comes to 62.5 milliliters per hour. Number three, this is going to be done just a little bit different. If a 1,000 milliliter bag of normal saline is run at 100 milliliters per hour, how long will the bag last? So this one we have 3 parts, so we're going to do ratio proportion with it. So you have 1,000 milliliters. That's going to be over extra time, X hours. And it's telling you, of course, that it's going to be run at 100 milliliters per 1 hour. Okay, so then we can cross multiply. X times 100 is 100. 1,000 times 1, that gives 1,000 times 1 is 1,000. Okay, and then of course we can cross 2 zeros out here to here. And this 1,000 milliliter bag will last 10 hours. Number 4, a sterile solution request form is received for a large volume parenteral. The infusion rate is 125 milliliters per hour. The nurse requests enough 1 liter bags for the next 24 hours. How many bags do you make? Okay, so we have our 3 parts. So we'll do this one in a ratio proportion form. So you have the infusion rate, of course, is 125 milliliters per 1 hour. Um, the nurse is going to request enough 1 liter bags. She wants 1 liter bags. And we're going to want to know, of course, how many bags to get. So first we're going to determine the amount of hours that you're going to get out of 1 bag, so X hours. And this is milliliters, liters, so take this into, make sure they're the same. So 1 liter is equal to 1,000 milliliters. Okay, cross multiply. 1,000 times 1 is going to go on top, it'll be 1,000. 125 times X will be 125X. Okay, you divide it, you get 8 hours. Okay, so we know there's 24 hours in a day, divided by 8. So you're going to need 3 bags. Number 5. Again, we can do that in a ratio proportion because we have our 3 parts. If the infusion rate for an IV is 80 milliliters per 1 hour and it run for 4.5 hours, how many milliliters has the patient received? So you know it's going to run 80 milliliters per 1 hour. And of course, we know it's going to run 4.5 hours. So we need to find the X milliliters. Okay. Our units are the same on top and the bottom, so X times 1 would be 1. 80 times 4.5 would be 360. So your total would be 360 milliliters. Number 7. I'm not going to worry about doing the military time, so you can just skip over number 6. Number 7, potassium chloride 30 milliequivalent is to be given in 1 liter of IV fluid. The infusion rate is 125 milliliters per hour. How many milliequivalents per hour are going to be infused? So it's asking for milliequivalents per hour, and it's giving you that you have 30. This is number 7. 30 milliequivalents per 8 hours. I'm sorry about that, because you go back a little bit. So you have your 30 milliequivalents. It's given in 1 liter, of course, of fluid. The infusion rate is 125 milliliters per hour. So what I did is I took, I'll put it down here, your 1,000 milliliters, which was a beginning, your 1 liter, and then I just converted it to milliliters. I divided it by the 125 milliliters to get 8. Okay, for the 8 hours. So then you take your 30 milliequivalent and divide it by 8. And you get 3.75 milliequivalents per hour. Okay, number 8. You have a 50 milliliter IV piggyback bag of ampicillin, 500 milligrams, in normal saline, and is to be run over 20 minutes. What is the infusion rate in milliliters per hour? Okay, so this one, you have your volume, 50 milliliters, and you can put over your time, which is minutes. Okay, 20 minutes. But you need to figure out how much it is in hours. Okay, so we know that there's, 20 minutes will go into 1 hour 3 times. So then you just multiply it by 3. each one. So 50 times 3 would be 150 milliliters, and then the 3 times the 20 would be 60 minutes, which would be 1 hour. Those are one answer. So it'd be 150 milliliters in 1 hour. Number 9. And because these are every one of these are a little bit different, I'll do a little bit more problems. Probably go through like 12 problems. Number 9, an order is for heparin IV to infuse at 1,000 units per hour. What will the flow rate in milliliters per hour for a 500 milliliter bag of D5W with 25,000 units of heparin? So first we need to figure up the hours. So you have 1,000 units for 1 hour. And of course it said that it wants to be with 25,000 units. Okay, so we're just going to cross multiply that. 25,000 times 1 would be 25,000. 1,000 times x would be 1,000. Again, you could cross out your zeros here. And it should come up to be 25 hours. Okay, so now we're going to find your milliliters per hour. So you take your 25 units per 1 hour. Okay, and then next what you're going to do, of course, is it says it's for a 500 milliliter bag. And we want to know how many hours is in that 500 milliliter bag. So then you're going to, that's supposed to be x, sorry. Cross multiply x times 25 be 25x goes on the bottom. 500 times 1 be 500. Divide it and come up to be 20 milliliters per hour. Next, number 10. You have a patient is on heparin drip, which is 12,500 units in 250 milliliters of 0.45% solution of sodium chloride injection. He is to receive 1,500 units per hour. At what rate should the drug be infused? So you're going to first figure up how many units per hour. So we know we have the 1,500 units per 1 hour. Okay, and the patient is supposed to be on a 12,500 unit. So then you're going to cross multiply. 12,500 times 1 be 12,500 divided by 1,500 times x is 1,500x. Again, you can cross out your two zeros, make it a little bit easier. 125 divided by 15. Of course, it's going to be 8.33 units per hour. Okay, so next you're going to take that 8.33 units. We know it's per 1 hour. And we're going to figure up, of course, it's that 12,500 units was going to be 250 milliliters. So we put 250 milliliters for X hours. Again, these are units is liquid. Okay, so 8.33 times that H or X, excuse me, is 8.33. 250 times 1 is 250. 250 divided by 8.33, you get 30 milliliters per hour. Okay, number 11. This is just a ratio proportion one, but then we have to change our time on it. So how many drops per minute will a patient receive if an IV of 1,000 milliliters of 5% dextrose injection is run in over 8 hours? The drip rate or factor is 15 drops per milliliter. So we know we have your 1,000 milliliters You have your 8 hours. So you have 100, or excuse me, 1,000 milliliters. We're trying to find how many drops. So I'm going to put X drops. Okay, your drip factor is going to be 15 drops per milliliter. So you have 1 milliliter and 15 drops. So cross multiply. 1 times X is 1. That's supposed to be a 1. 1,000 times 15 would be 15,000. Okay, so your answer, of course, is 15,000 drops. And those 15,000 drops, of course, is going to be run over 8 hours. So then we need to divide it by hours. But they want to know, if you go back at the beginning of the question, they ask how many drops per minute. So what I do is it's over 8 hours, so you have 60 minutes in 1 hour, so 60 times 8 would be 480 minutes. So I go ahead and do that now. Okay, and then of course you're going to divide 15,000 drops per 480 minutes. You get 331.25, which of course should be round off. With drops, it will be rounded up regardless. So it'd be 32 drops per 1 minute. Okay, number 12, you have 100 micrograms of a drug dissolved in 240 milliliters of solution is to be infused at a rate of 75 micrograms per 1 hour. So if you have 1 milliliter equals 15 drops, what should the rate of administration be in drops per minute? So first, you could do a ratio proportion. So you want to take your 100 micrograms of a drug in 240 milliliters. So we know that is a given. And you're going to, of course, it tells you that it's at a rate of 75 micrograms per hour. Okay. And then we're trying to find X milliliters. We'll cross multiply. And again, you can mark out this. Sometimes you'll might have an extra unit up here. So when you do that, you can mark out the units if you have 2 of each one. Okay. So 75, 100 times X would be 100, goes on the bottom. And then, of course, you have your 75 times 240 goes on top. It should come out to be 18,000. Again, you can help that out and do 180 divided by 1. You have 180 milliliters because you're finding milliliters, but it's per hours. So next, if you look at the question, it's asking for what should the rate of administration be in drops per minute. So we have our milliliters per hour now. But it comes in, it tells you if the drops is 1 milliliter equals 15 drops. So then you take your 100, this is another formula, milliliters per hour. We're trying to find our X drops. Okay, you do have your 1 milliliters is going to equal to 15 drops. So we have our units the same on the bottom, units the same on the top. Of course, we still have this because that's what we're looking for. Okay, next you're just going to cross multiply. X times 1 goes on is 1. 180 times 15 is 2,700. So your answer is 2,700 drops per hour. But we want it per minute. So we're just going to take that's in 1 hour. So there's 60 minutes in an hour. So you just divide that by 60 for 60 minutes in 1 hour. And that allows you to mark the hour off. It gives it 2 drops per minute. So 2,700 divided by 60 would equal 45 drops per minute. Some of these questions are, most of them are volume over time equals the rate, but sometimes you have to, they're just pretty much like word problems. You have to figure out what are they asking for. Okay, so, and I'll try to teach students to use the volume over time formula, but you could also use ratio proportion formulas if you know the 3 parts. If you have any questions or concerns, just send me an email.